Okay, this is the start of tape label number 1 of a videotape demonstration by, I'm sorry, what's your name, sir?
Tom Gilly.
Tom Gilly, in the matter of certain electronic digital media devices and components thereof before the United States International Trade Commission, investigation number 337-TA-796. This demonstration is being held at Morrison and Forster, 1290 Avenue of the Americas, New York, New York, on March 15th, 2012, at approximately 7:29 p.m. My name is Jonathan Popham from TSG Reporting Incorporated, and I'm the legal video specialist. And did you want to introduce yourself?
My name is Karen Hagberg, and I'm an attorney at Morrison and Forster here on behalf of Apple. And Sunny Yuen is also in the room. She's also an attorney at Morrison and Forster.
Okay, I think we're all set.
Okay, Tom, do you want to describe what that is?
Yes. So what I'm holding is a penlite pre-production. This unit's been completely tooled and textured plastic, so we know that it's just about to go into production. But it has a couple of pieces that aren't textured, so we know that this is a test unit. It's a pen-based computer that's built off the Macintosh Duo portable. It was, at the time, one of the lightweight, small laptops from Apple. And what we did was we repurposed that platform and turned it into a pen computer by taking the display out of the clamshell and putting it into a unit that could be held and used by the pen. The Duo platform also had a docking unit, which is not at the table, but this docks into a unit which then you would have a hard drive and a laptop, a display, and then a standard keyboard and mouse. So this worked quite well in that environment. And what I have running on here is about the Macintosh. I have system software 7.1. It's got about 12 megabytes of RAM, it looks like, and this usually shipped with a 120 hard disk drive. And this is the electromagnetic pen. It is battery powered, so it's emitting a radio frequency. Behind the LCD display, there is a XY grid that picks up the radio frequency and converts it to coordinates, which are fed into a controller, into a serial interface. And there's a serial interface on the logic board for picking up the pen as if it were a mouse. And there's a driver that was written to emulate a mouse. And as I click down with the pen on the Finder window elements, it recognizes that that pen touchdown was on a active element. It'll do whatever that active element was meant to do. So for instance, this is the drag bar of the window. I can drag the window, select a window that's underneath, drag it around. I can double click to open up a folder, click the close bar to...
Maybe just slow down just a little bit.
Mm-hmm. Has several states, so the pen right now is lifted about a ½ inch above the display, but it's still picking up XY coordinates, a pretty good resolution, so it knows where the pen is hovering on the display, and then as I touch the tip down, the tip has an actuator, changes the signal from the pen. It recognizes that as a mouse click and then emulates the mouse click in the Finder. What's unique about this is the Macintosh operating system in the Finder was built as a remote control interface with a mouse and a cursor, and we've now emulated the mouse with the pen. And there are several software modifications to the penlite. make it unique. I think one of the more interesting modifications is running in the background. There's an application called Rosetta, which was Apple's handwriting recognition software. I've just launched a text editor, and I can select, a point in that text editor for editing. And if you touch your pen down on a non-active element and start to write, it'll write on a translucent layer on top of the display. Looks like this. And as the recognizer recognizes the characters, it'll start typing them as if it were typing with a keyboard. I can select the text. And this is based on neural network technology, and it gets better and better the longer that I use it. So now I can touch down. In the text, and as it's recognizing it, it types as if it were a keyboard. And this can be done not only within a text editor, but in any text element within the computer. So here's a folder. I can click and drag that folder as if I were a mouse. I can select the text of that folder and type in a new word. And it should recognize that and type it in that location where the cursor was within the text field. In this case, it was the folder name. So what was unique about this software-hardware combination is the emulation of the mouse and a keyboard by presenting a translucent layer on top of the operating system, so that you could go between mouse move to text entry. There's alternative ways of entering text, which is called the pen board. There are several development teams working on this project. This is a special project between Advanced Technology Group, the Portable Group, and the Apple Software Group. The handwriting recognition came out of the Advanced Technology Group. The hardware came out of the Portable Group, and then the modifications to the software stack, the Finder and the various applications that I'm demonstrating came out of Apple's Finder development group. So what I've just launched is what's referred to as the pen board, and this pen board emulates a keyboard, and I can do the same operations that I did before, but instead of writing on the tablet, I can click on the keyboard. Now this pen board is also sitting on the translucency layer, and I don't actually remember how to make it translucent. So
Okay.
I'm not going to be able to
Okay.
to do that. But the concept was that any compute object that wasn't a part of the fundamental Mac operating system, the Finder, which is the windowing environment of the operating system, or any other native application, would be compatible with penlite by offering that translucent layer, and then these new pen-aware applications operating in that translucent layer.
Tom, could you actually write a document and have the document appear in a typed format?
Yes. I'd say most commonly the use case when we were presenting it to customers or potential partners is that it was used for taking notes, for working on diagrams, navigating. So it was light pen use. It would be light text entry. It would be mostly navigating, and then as you and taking of notes. And those notes would be saved in its graphic format as well as in its recognized format. And then you'd bring it back to your docking station. You would dock it, and that's where you did your heavy word processing. So this,
You just tilt it a little bit more toward camera.
this particular computer is interesting in that it has a lot of, this probably was one of my demonstration computers because it has some old projects on here. Here is a HyperCard stack. Some of the very early prototypes were really HyperCard playback devices. And this is,
And I'm sorry, sir, if you could just sort of tilt it more parallel with the lens. Thank you.
So what I've just launched is a HyperCard stack, and this was actually the first experiment in pen capture. And I also don't remember exactly how this works.
So that's one of the programs that's on there, is that what you're
Right,
saying?
I'm just bringing up one of the old programs. Oh, I see what it's doing. So I'm training it. That's not so exciting.
So
But
when you dock it, does the content that's on there get stored to the hard drive of the docking station so that it's cleared, or
no,
not? Okay.
the docking station has a hard drive on it, so it would be similar to plugging in a hard drive to this unit.
Okay.
So you'd still have all your files and
Your
operating
local.
environment here, and then you would plug it into the docking station. And the other concept that we had, and this is a prototype, but it would be sold with a case that would stand it up, and then there would be a keyboard that you would attach to the device, and then probably a mouse. And this stand is also a case, and it folds up, so you can articulate it like this and fold it up to carry it around. All right, so we'll just go through. This has one of the original Rosetta installations, and you can see it has its neural network training files. It looks like it has its languages. This was written by Larry Yeager and a bunch of smart engineers at Apple. So that's on this computer. And then, the other thing that's interesting I noticed on this one, it has the tablet driver. This was integrated into the control panel, but this is actually the diagnostic window into the driver for this tablet computer, and it actually shows we had many different versions. So this one's the penlite Gazelle. Gazelle is the name of the tablet. We also have the Ansel Scriptel tablet, the Walt U-Touch, Wacom, several other different experiments that we were doing in hardware around pen and finger-based computing. And so this has also there were iterations of this computer not brought to production that had pen and finger. The finger would be used for navigation, changing, scrolling the window, or flipping through pages, and then the pen for writing. This particular tablet does not have the finger interface on it. The pen driver was really well done. Actually, what's interesting, if you take a look at the ink, it's very fast. You have to remember I think it's a 25 megahertz processor, and the ink appears to be coming out of the tip of the pen really smoothly. There are two major reasons for that. One is we assured that the resolution of the tablet was 2 or 3 times greater than the display resolution. And then we also have a Kalman filter for predicting where the pen's going to be in the future. So as you're moving very quickly, it's doing a trajectory analysis to determine where the pen's going to be in the future. So the ink is actually writing ahead of where the data points are coming from the tablet, and that's why it looks so smooth. I pick up some of the modern tablets and do this, and their ink is lagging behind the tip of the pen because they're not doing that. And I think I saw a source code on here someplace.
Just trying to tilt our
Yeah, I think. Documentation, penlite. So this is all the documentation for the product. These dates look accurate. It was fall of '92. Okay, here it is. So here's the pen toolbox and sample code. Sample code might be test code, not the actual code for the pen tablet. Well, someone had asked me what was Pendragon and how that related to penlite. This is penlite, which was the product code name. I think they were going to call it Apple Pen Duo, or Duo Pen, I think is what it was going to be called. But penlite was the name of the main product, and then the Pendragon was the Finder team. So the Finder team managed under Fac Latoine. I can't remember all of the managers. This is where Michael Goff and the others were employed. They were on the Finder side, and their contribution to this product was the pen board and interface, and then several sample applications. This inking layer that I'm actually using on this portable, I can tell it was written by Gina Vanolia, who's on the 922 patent. That's Scribble. I'm quite confident they took Gina's code and then incorporated it into their own driver, which is not what's on this particular device. The reason I think that is because I have Rosetta on here. And Rosetta wasn't actually shipping on the penlite or the Duo pen. The first version was a katakana kanji license from a company called CIC. I don't remember what that stood for. Computer or something. Yeah. And what else do we have on here? Sample tools. There was a really innovative math program which still ships with Apple today, or at least the Generationally, it's the same. It was handwriting recognition, math application. See if it's one of these. Okay, that's one of their applications, what that is. Okay, these are training. This is a training. Application for the handwriting recognition. Oops.
What's the training application?
There's a couple of code name applications on here. It was called Kalimero, Calimero. This these are sample applications. Some of them are working, some of them aren't working. That one's definitely not working. So those are sample applications on top of yes. I think most of these
On top of what?
applications, I think these are all Pendragon
Okay.
applications. Yeah. What else do we have on here? I'm just exploring, seeing if there's anything interesting.
That's good.
Penlite User's Guide, yeah. Let's see if it's... Yeah. So Rosetta's still in the background. And yeah, there's not much more on here. If there's any, as I was saying earlier, any application that would run within the Mac would work with how we integrated the pen, so it was backward compatible. There's no adjustment to any of the applications that were available. That was pretty unique at the time.
And since I'm not looking at that and can't see, can you just one more time just give an example of how you can write something and have it show up in
Sure.
a text box, or
No problem.
just so it's we
I'll
make
do it
sure we
again.
have that.
Yeah. There's on this computer, the brightness and contrast were adjusted outside the application. I think remember the concept there being this particular display is a super twist display, and the brightness and the contrast could drift over time, and it was important to have it external. Modern displays are active matrix, and they don't drift. There's a special connector here. This connector allowed you to attach the keyboard and mouse and other devices. This is for modem, and this was for printer. And there's a large docking connector here that brought out just about all of the internal functions of the portable so that it was available to the docking station. Extended the hard drive, the memory, the serial port, the USB keyboard. Oh, that's not USB. This is ADB. It's pre-USB, Apple Desktop Bus. And okay, well, you wanted to write on something again, so let's do that. So I'm navigating the Finder. I'm launching Teach Text, which is a text program. I'm opening up a window. I am writing very poorly. Does an okay job. I'll try it again. So there it is. That worked out well. And as I mentioned earlier, we can bring up the keyboard. It's being presented in the translucent layer, and I can do anything that I would do from a keyboard. This is fairly standard practice on today's pen computers, is to have a keyboard. What's really unique, I think, is that it has the translucent layer for the inking that lays on top of any existing application without modification, and you don't have to write in little boxes in a window. Surprised there isn't a paint program on here. The pen actually has pressure, so there's pressure sensitivity in the pen. It was very unique when we were developing this computer. Apple was also developing a Newton, and they were having difficulties with their tablet design. And this was the first electromagnetic tablet that was integrated into a personal computer. Most electromagnetic tablets were done as a tablet outside the computer. And one of the reasons is the electromagnetic frequency from the pen, and all of the frequencies within the computer would interact and create a very poor resolution tablet experience. Actually, a lot of distortion as well in the tablet. So what that would be is not as responsive, not as high resolution, lots of jitter. So as you had your pen close to the tablet, there'd be a lot of jitter. And what we did was created a test robot that tested the pen on the tablet as it was integrated into the computer. This is what the Newton team hadn't been doing. They've been testing their tablets away from the computer, then try to put it on the computer, and it wouldn't work. But we were testing the tablets on the computer so that we were we were testing not only the tablet, but also the tablet ability to recognize the pen, but also how the computer and the computer subsystems interacted with the electromagnetic fields of the tablet. And what it turned out is we actually created a map, a frequency map, three-dimensionally, and then adjusted our driver. This is another Gina Venolia. So the driver actually adjusts for the interference from the underlying components of the computer. Probably most significantly is that the backlight here is an AC-driven fluorescent tube, not LED. It's actually fluorescent, so the voltage is very high and the frequency is high. I think the voltage was, I hesitate to say, I can't remember, but it was quite high, enough to put a hole in your finger, which I did several times, and that driver for the fluorescent is actually to fit in this unit laid out on the back of the tablet. We worked with linear devices, or creating the analog components for the fluorescent driver, and we managed to get the backlight driver on the back of the tablet and have the tablet still be high resolution and minimal distortion and very responsive. That was a very large feat. I think probably a few years ahead of its time.
Just go through, start pushing the tripod later. And
there's the pen board. And this is a very early version of the Pendragon. It's not really what was released. I'm finding. Close. Here we go. Let's see if we get this to work.
Could you draw pictures and have those appear on
Yes.
paper when you put it in a docking station?
Yes. You could take notes, and the notes would be saved. I'm launching a graphics program. See if it works. It doesn't seem to be working. Yeah, looks like it locked up. Yeah. That's the secret button. Yep. So we're booting the computer. It's the Happy Mac. And we should see these are the driver loading here. though that happened pretty quickly, but there was the scribble, the pen, several drivers were loaded. Try another. Oh, I don't see what this does. I think. All right, good. So right now, just that what's operating now in the background is the translucent layer with the pen interface and the inking. So no matter what I do on the display, it's capturing those coordinates, presenting the ink on the translucent layer, but there's no place to pass that information to. So in this particular implementation, this is very much pre-production. I have to launch the handwriting recognition. But what I'm going to do is, instead of launching Rosetta, I'm going to launch the pen board and make sure that doesn't have recognition built into it. So this is pen board. Right, so this is just the pen interface. So I can type characters with that pen board. If I recall correctly, actually when I click this button, I am there was a way of turning on notes that would be presented in the translucent layer and turn them off, but I cannot seem to get it to work with this version of the software. That was answering Karen's question.
Mm-hmm.
And so now I'm going to launch Rosetta. This was also really quite unique for the time. You have to remember this is a 25 megahertz processor. This is actually a neural network, so it learns as you use it. Oh, Rosetta launch. So now I've got it launched. Oh, is that really true? Oh, this might be interesting. There used to be a debug mode in Rosetta which would actually show you its neural net. Let's see if it works. Show all. So, yes, so it's showing me its decision tree. There was a much better version where it demonstrated it graphically. Larry Yeager wrote games So he was pretty good at making it look cool, but not this version. Yeah, it's not very exciting. Wait, maybe? Image? There it is. It does have all the good stuff. So it makes it go quite a bit slower. What we're doing is we're looking at a window into the image recognition that's a part of the neural net, and then the weights around the strokes represented in graphics or textures. That's pretty cool. It's also pretty slow. So we'll hide those windows. So what you should be seeing as I'm working through this is, again, as this is a unmodified Finder environment, windows and applications with the translucent layer on top. I believe the LCD controller in this device was done by Cirrus Logic, and we did start to talk to Cirrus Logic. This is before graphic processing units, GPUs, and we talked to Cirrus Logic about doing the translucent layer in the LCD controller memory, accessed memory, as opposed to the host memory. It's not implemented here, but assuming that this was going to be a successful project, we started to plan and design that. On the patent, that was mostly Abe Oswald. Pen fits here. It's kind of an interesting project in how to get the pen to stay. There's a little fabric strip in there that it's called mohair, so the hair is going in one direction and not in the other direction, so the pen goes in easily but comes out hard or harder. And the other interesting thing we did was the tip. We had different tips, types of tips, Teflon coated tips or Delron tips, or that would give you a different feel. And then the glass was made by Donnelly and then had a anti-reflection coating, and also a coating which I wish they had today, but the index of refraction of the coating was very similar to the grease of your finger. So if you can see that I'm touching the tablet, but you can't see the fingerprints easily. And that's because the index of refraction of the coating on the glass is very similar to what it is when the oil of your fingerprint is on there. Lots of things we've thought about. And because we have a texture and there's a particular tip in here, I think this is I can't recall. I think this is the Delrin tip. It has a scratching sound to it. We wanted to try to have a little bit of friction so that folks would say, oh, it's not that different than writing on paper. And what else? That's all I can think of. Speaker, battery. We tried to make this as rugged as possible. We did lots of drop tests. We experimented with different ways of mounting the fragile components. There's actually a carrier for the LCD that was remanufactured a few times so that it would be able to handle drop tests. I won't drop this, but we had several inches, several feet. And when they canceled the project, more as a team building, we had about 100 people working on the project as it was going into manufacturing. And we had our final meeting when they canceled the project. I pulled everyone together, and we were just finishing drop testing. And so we decided we were going to do the big drop test off of the city center, which I think was 8 floors or so. And I got in trouble with security, but it made a good video.
Do you still have it?
I don't. It may be on an 8mm or someplace, but no, I don't have that. And this is all finished on the inside. So this was just one step away before being a production unit. I know there are production units someplace. I just guess we didn't find them. The only thing that makes this a non-production unit is it doesn't have the Golden Master software on there, and that these flaps aren't textured. That's the only thing that's keeping it from being a production unit. So looking at taking this apart. I don't think there were any tricks. I think it came apart pretty easily. So when your guy comes tomorrow, he's going to take these screws, and then it's going to open. I think he has to remove there's a flex connector between the tablet and the motherboard, and I think he has to be careful. Maybe I'll be here maybe when he does that. I think I remember what I need to do. It was interesting. It was a skunkworks project, actually. When they were designing the motherboard for the Duo, they had no idea they were going to do a pen computer. And I was working with the portable team on some other projects, and the manager was Steve Young, not the football player, but he was a great guy. We did a lot of projects together, and I told him I could make a pen computer out of this. And then he actually had the motherboard designed with my connector on the bottom without anyone knowing. And so we created prototypes that looked very, very much like this. That's the one with the rubber flaps that you have in there. And people were going crazy over it, and that's how we got the project funded. It was a very fast project from the time that we demonstrated the prototype to the date of manufacture, and it only went a short run manufacturing. It was no more than 9 or 10 months.
Wow.
It was really fast because we had done most of the work prior. And I think I mentioned earlier there was a little competition between different groups within Apple. So there's the Pendragon group was one group, and then there's another group, and they were competing over the software. So that's why this one's unique in that it has both. It has some of the early Pendragon software, and then some of the ATG software. The ATG software actually survived and went on to be the handwriting recognition software for the Newton.
Okay, anything else there you think we should record?
I don't think so, unless you have any other
No, that was the
questions.
one. I don't have any other questions. Sunny, you think that's everything?
This is not the Golden Master production software on this unit.
So there's a Golden Master.
There was software that was installed on the units that were being manufactured and shipped. And if I recall correctly, it was Pendragon and the CIC kanji katakana handwriting recognition, because we were shipping to Japan. Japan, Tokyo, they actually had some customer base that was interested in it. And so the first run was going there. And then I think what was happening was the Rosetta, I believe the Rosetta code base was being merged into the Pendragon software, and that was going to be the US release. And that hadn't finished, and that's why it was going to Tokyo first and then the US. But it was canceled before the US version was done. Interestingly, there are a couple of projects that Logitech was working with Apple. So Apple didn't want to manufacture the pen because that wasn't its, it just didn't have the expertise to do the pen manufacturing. So it licensed the pen designed to Logitech, and Logitech was the pen manufacturer. And interestingly, the pen, you still see it. I've been in places where this pen, this exact pen,
Wow.
is being used for signing in to the desk or something like
Right.
that. Yeah. So someone picked it up. More than likely, we licensed the technology from a company in Los Angeles. So more than likely, they went on and created these little tablets for signature use. Yeah. So I can't think of anything else to
Okay, well, that's great. I think
to do on it.
that's good.
All right. Yeah, it's fun to walk down memory lane.
Yeah.
I wonder, is it okay, can I take a,
Yeah,
Just
yeah,
a-
yeah, yeah, of
right.
course.
Mhm.
It's yours.
All right.
You can turn off he's going to
Okay.
do his own film production.
Yes.
Okay, this concludes today's demonstration. We are going off the record at 8:21 p.m. This also concludes tape number 1.